Hello, everyone. Good evening. Welcome to Starry Nights and welcome to Vancouver. My name is Abby. So, before we start, we can test audio. And also, I forgot to introduce my co-host, Zena. Say hi to everyone, Zena.
Hello, everyone. I hope you're all doing good. It's still a little bit bright outside, so we probably may have to wait a few minutes to get darker to see the object.
Yeah, so before we start, I want to see if our audio is coming through, if the images are coming through. So, can everyone hear me and Zena?
Hello, everyone.
Okay.
I got the okay from Indira and Zachary. That's
Oh,
awesome.
thank you.
Great. All right. So,
So, yeah, we have to introduce our moderator.
okay. So before we get started, I would like to introduce our Starfleet officers, the moderators. We have Indira, Zach, and Jennifer. They will be the ones to answer your questions on the chat.
Okay, cool. Yeah, so as we said, it's a little bit bright here since we are really we're in the north, we are high up, in the latitude that's over 40 degrees, so it's still actually pretty bright out there. And actually for Vancouver, we don't really have proper nighttime during the summertime. It's only astronomical twilight. We don't even really have a pitch dark period. So yeah, summer we have nice weather. It's kind of nice time for stargazing, but it's also a bit frustrating that we don't have a proper nighttime.
That makes sense. This actually explains why June is a tricky month because, especially for very far away and dim objects, because as we know, June is most of the time it's bright and the days are very long. And now you just learned that we don't really have a true nighttime.
Yeah, and actually, just on Tuesday, I think the June 20th, it's actually summer solstice, which means it's the longest day of the year for us, for northern hemisphere. But for southern hemisphere, it's actually the shortest day. So
So the days are gonna get shorter.
yeah, so let's try to get our first target. So now, yeah, we're pointed at the Hercules cluster. It's a globular cluster. So yeah, so it's a little bit bright out there. So the telescope could be picking up a lot of photons, also from the sunlight and other objects, rather than the star cluster. So yeah, this is something that could be a little bit trickier during summertime.
We can maybe, while trying to figure out how to get the object, I don't know if there's a cloud covering the telescope or is it just because it's still bright out there. But maybe for those of you who don't know what a globular cluster is, you can even look it up online. It's actually just from the name suggests. So globular cluster is just a massive collection of thousands of stars, and all these stars they are bound by gravity, and that's why when you look at the photos or when you look at our images once it works, you'll see that most globular clusters, they have a spherical shape. And the reason for that, because all these stars are going or they're attracted towards the center. And I always wondered why or what was happening in the center or what exists in the center. And I thought maybe there is a black hole. But then again, when I was looking up at the literature, there is no any evidence of detection of a black hole in the center of the globular cluster. So who knows what's actually attracting those stars to some form of a center. And then later on, we're gonna see that there's the opposite of somewhat the opposite of a globular cluster called an open cluster. And an open cluster is just you have less collection of stars, and you'll see that there's it's like you still see stars somewhat they're going towards the center, but not yet. So the idea is that an open cluster will become a globular cluster one day in a billion years.
Yeah, and I think
And
you're
there was
right.
no black hole detected at that time as well. Sorry, go ahead, Abby.
Oh no, also I think you're right. So it turns out it seems like there are a thin patch of cloud out there. So now we're trying to point to a different target and see if we can try to get the objects out. And yeah, so just now you can see me browsing around. That's the SkyX software. That's the software that we use to bring out, like, to search for the stars and to point at different targets.
Yeah, it's it's still pretty bright outside. All right, while say Abby figuring out the tech, maybe does anyone have a favorite planet? Put it up in the chat. I know what's my favorite. What's yours? Mine is Saturn. What about you, Abby? What's your favorite planet?
I have a hard time picking in between Jupiter and Saturn. Like, they're both really cool planets, and I really like them a lot.
They are gigantic. I personally like Saturn because I don't know, and then at first I never knew why, for some reason, why I like Saturn, maybe because it has the rings. But when you actually think about it, and when you compare Saturn to the other planets, when you look at the planet through the telescope, it's a 2D version. It feels like it's a 2D, if you understand what I mean. But when you look at Saturn's the only one that feels like it's 3D. So I like that aspect. So I think maybe that's the reason why I'm gravitating towards Saturn.
Well, we do have, like, Saturn and Jupiter. They're so popular, and oh my goodness, someone they like Uranus. Yeah, I like the blue planet, like bluish green. It's so beautiful.
Oh yeah, our moon, our favorite moon. Which moon are we talking about? Somebody said the moon. Are we talking about our moon, the Earth moon? There's so many moons out there. Oh, I like that. Earth, of course. Other than Earth, of course, Earth is my number one too. I don't want to live anywhere but Earth. But my second favorite would be Saturn. Not necessarily I would want to go live there.
Yeah, so right now I'm just trying, because we are planning on talking about globular clusters, so I'm just like looking at the map for a globular cluster. So if some of you have Stellarium or STEM's like stargazing app, actually, like, for globular cluster, you can look for a logo that it's like there's a cross on it. So those indicates globular cluster in the sky map. So now I'm just trying to point at a like random globular cluster to see if we can, like, point at some objects that are, like, away from the clouds and see if we can get lucky.
Getting darker out there, at least from my window.
Yes, it's getting darker out there.
Oh, I think somebody was asking about what are those red and blue, red and green dots?
Oh, that's a good question. So for the red dots, there are galaxies. So if you put in close up, it actually looks like a flower shape. And for the green dots, they're mostly the planetary nebulas and star clusters. So if you zoom up, if it's a star cluster, you can see kind of like a tool icon on your phone. And if it's a planetary nebula, it's just a green circle with a blue dot in the middle.
There you go. There's a lot of them.
Yeah.
Yeah, wonder what's that white patch?
Yeah, I'm wondering. I think there must be some problem with the there could be some problem with the telescope, but or maybe the camera. I could try to check to see if we are having the right camera on. Yeah. Okay, yeah, we have our camera on. We are on the right camera, and okay, so if maybe we could try to point at something that's not a cluster.
Maybe Can you point in the other direction?
Yeah, I could try to point at M57. So we've been talking about clusters and stars. So let's see what happens like when star dies or maybe when star gets old and see like how they look like. Yeah, so you can see that like the yellow dot it's actually our telescope camera and the slit it's the dome and the slit in the dome that's moving around. So it's trying to align with each other and connect so we could see the night sky.
And yeah, I think that area where you see like that's the dome, that's the direction of the dome moving.
Yeah, it is. So here.
And I think also you can see it in the camera, kind of. You can see the kind of the dome moving.
Yep, we're almost there.
Sorry, folks, we're having some technical difficulties on the ship. Please stay tuned.
Yeah, we're having some technical
Oh, I see.
difficulties right now, and
Hmm.
so yeah. While we're here trying to solve technical difficulties, since we're looking at nebula, maybe like you can share with us like what's your favorite nebula?
Oh, that's tough for me. I think maybe I don't know if the audience, the majority of audience know what a nebula is. I think most people have heard of a nebula. Um, so I think nebula. Not I think I know what a nebula is. So a nebula is so stars go. They also go through like birth and death. But some stars they transform into a different type of celestial object. So if the star is of a low mass star or a medium size, they go through what's called a planetary nebula, and that's what we're trying to get you to see. So the planetary, those stars, those low mass stars, they will actually turn into what's called a white dwarf. But if we were looking into a high massive star, then those stars will turn into either a neutron stars or they will turn into a black hole, and they will go through what's called a supermassive nova.
Or a
So,
like supernova?
yeah, but our star, for example, our star, the sun, it's it's gonna go through a planetary nebula because it's considered a low mass star, and it will turn into a white dwarf. And the best way to describe what a white dwarf is, it's a diamond, like a diamond in the night sky. It's like the white dwarf are the size of Earth. So picture it, diamond, size of. I think this is a good time to get the telescope tech to figure out what's going on. But I think from the telescope cameras, it looks like I think it's just really bright outside. Oh,
Hello, Joanna. Sorry, yeah, it's me again. We're having some issues. So, yeah, are you on the live?
the tarantula on the
Sorry, are you on the live stream? Cause oh yeah, no worries. Cause nothing is working right now. It's just not keep stacking and keep having some whiteout frames, and the histogram is on the other
running
side. So
class.
I'm not quite sure what's happening. We're pointing on the north. We're pointing northeast at the Ring Nebula. Yeah. The moon isn't out yet, and we tried two different clusters earlier, and we are still having the same effect. So, yeah, I'm trying to keep the audience. Yeah. Yeah. So, yeah, I'm trying to keep the audience like connected. Okay. Yeah. Sorry. Okay. Okay, so now we're trying to calling like Joanna for help. She's like our professional stuff, so yeah, we'll see then. Hopefully, finger crossed, everything will work out.
Yeah. Yay, Joanna to the rescue. She's Picard.
Yep. And we're Starfleet
I was Picard.
officers.
Yeah.
So
I
yeah,
don't know if you heard me. I mentioned what's my favorite nebula, and mine is the Running Chicken Nebula. I don't know if anybody has heard of it. It's in the southern hemisphere. Unfortunately, we can't really see it from here, but it really looks like it's a running bird if you were to go and Google it.
Okay, M5 is it? Okay, I'll. Okay, yeah, okay, I'll try that for now. Okay. Okay, I'll try to point at M5 for now. Okay, so we have some, yeah, so now we're trying to look at a different target in the south, so that would be easier for everyone, and yep, finger crossed that hopefully it'll work out.
Somebody asked a question.
Ooh.
Why is it called a planetary nebula? And yeah, there's nothing fascinating. There isn't a fascinating story behind the name. It's just Messier. When he described a nebula, he described it a plant-like object. It looks like a planet. So that's why it's called planetary. That's the only reason.
Yeah, and actually Messi is like the person who he's not really interested in like searching for nebulas, galaxies, and star clusters, but he's very interested in looking for comets. So if some of you have looked into the comet neowise from last year, if you look into your binoculars or your smaller telescope, it shows up as a fuzzy patch. So if you're looking at some of the Messier objects, such as the Globular Cluster or Planetary Nebula, it also looks like a fuzzy patch in the night sky. So in order to prevent confusion, Messier kind of cataloged something that it's not a comet. So in this way, it's easier for him to try to search for something that's actually a comet. And actually, at the end of the day, oh, we're getting something here. Okay, it's cool. Yeah. So actually, Messier spent his lifetime like searching for comets. He only find 7 comets at the end of the day. But it's really great we have a really giant catalog that we can look at the night sky and try to like for us like as a direction for stargazing and for a lot of different types of research.
And it's funny that astronomer like Messier, he found almost everything else in the night sky except for a comet. I found that ironic.
Yeah.
Alrighty, we are seeing something, and it's what is that?
So we're looking at a globular cluster, everyone.
Woohoo! Yay! We got our globular cluster. All right. Thanks for waiting.
Okay, yeah, we got something now. Thank you so much.
Okay, good. Yeah, I can see that your sky background is very, very bright. It's just because the sky is just really bright. I suppose we could have started at 10:30, then it was very late. But that's the reason. So you can explain that at this time of year. And that's another good talking point for you. You can talk about the summer solstice at this time of year because we're so far north.
Oh,
The sun sets
yeah,
very
let's
late.
talk about
The
it.
sky stays bright all night long.
Yeah.
Yeah, so it's yeah, that's the reason. I can see that your sky is bright. It's not bright blue, actually.
Yeah, it's okay. Okay, I gotta go back to talk about this cluster now. Yeah. Sorry, but thanks a lot.
Okay. All right.
Okay.
You're doing well.
Okay.
You're doing well.
Okay, thanks.
All right. Bye.
Bye.
You did it. You did it, Abby.
Yo, okay, yeah, really good. Yeah. Thanks,
You are
everyone. Thank you for
number
being so patient, everyone. So, yeah, now let's talk about M5 clusters. So I remember last year I was also looking at M5 cluster. It's actually a really beautiful cluster. So when I was looking into the binoculars, it's really like a fuzzy patch. And it's just really nice looking into a scope. Like I really miss that feeling a lot. Do you, Zena?
Yeah, for sure. Yeah, same for me. Is this M13?
So this
We're
is
looking.
M5. This is the
Oh, okay.
M5 globular clusters. So M5 is actually very like similar to M13. So if you're talking about globular clusters, we do actually have like there's like a system for globular clusters. So it's called the sharply Sawyer concentration class. So for M13, our original plan was that like, but yeah, we're looking at M5. They're very similar. They're also called the class 5, which is called intermediate globular clusters, which means they're quite compact. So the Sharpley-Sawyer concentration class is actually a system like for defining how concentrate a globular cluster it is. So the smaller number it is, the more compact it is. The larger number it is, the less compact it is. And it's actually quite interesting because some class 12 globular cluster actually looks like a open cluster, but they're globular clusters.
That's very interesting. I did not know that. That's so cool. Actually, when
Yeah.
I'm looking at this, I don't know why I thought it was like it looks like the M13, the one in Hercules. Yeah, it has like a very similar shape, but I think Hercules, now I think about it, has there's way more stars. But I like how this one in particular, has a lot of red, like the orange kind of color of stars. Because when you think about the age of those clusters, because there's always the aspect of time when it comes to space, the time it took for the light to travel to get to Earth, to get to our eyes, more specifically. So these stars, they look like red slash orange stars. Because when you compare them later on, if we get the chance tonight to look at an open cluster will have more bluish stars, which kind of makes sense because the stars reflect the age of the object. The more bluish, the blue stars are considered young stars, young and very hot, and the orange red stars are considered old and cold.
Yeah, look, it is like really interesting. And actually, blue stars they are hotter stars, and the red stars are the colder stars, which is kind of a little bit like opposite, maybe like from what we know, like when you see like some when like usually like on Earth like or what we think about okay blue means cold red means hot you can see the color scheme of different graphic designs but yeah but actually like in space when you're talking about stars the red stars are the colder stars and the blue stars are the hot stars.
Yep. So from an Earthling perspective, we just came up with an oxymoron. It feels like I came up with an oxymoron. Cold red star, hot blue star. It feels weird saying that.
Yeah, it's really weird. And one interesting thing about globular cluster is that if Earth is revolving a star in a globular cluster, we wouldn't have nighttime. I remember in one of the Starry nights on Imagine, yeah, it's ultimate like pollution because you'll just see like a lot of really bright stars, maybe looking like the sun or looking like the moon in the night in the sky. So yeah, you'll just be in the daylight for the entire day. which I could not imagine what life will be.
Oh, yeah. Imagine if we were living inside a globular cluster, like maybe our solar system would be within those globular cluster. We'll probably will never even experience nighttime. We'll probably never even see the stars like the way we see it right now. I wonder what kind of civilization would that be.
I'm
Oh,
pretty sure.
wait a minute. We do have a group of people who have that kind of experience, but they don't. But they have it for 6 months. I wonder what that's like. The one who
Yeah,
lived
I
in
wonder it will be very different because for us we are living on Earth, we're just revolving around the sun. We have a really good resource and access to our night sky, so we could learn about it. But if we're in globular clusters with that presence of a lot of stars around us, if I'm pretty sure like the perception of the universe would be very different. Maybe for them like it's just a lot of big stars around them. So yeah, for example, like just maybe like 100 or maybe 150 years ago, our perception of the universe is just our Milky Way. It's not until people they look deeper into the sky, they found Andromeda galaxy. Like that was like one of the time where our perception of the universe changes. Like we're not the only galaxy. There's way more stuff out there.
And that wasn't that long ago when you think about it. When we thought we were we were the universe. Our Milky Way was the universe. That perception that you were talking about, it wasn't that long ago that changed. That when we found out that there are
Yeah.
universe, there's like multiple galaxies. Because and beforehand, Andromeda, it was actually I think it was Hubble. He's the one who discovered that or proved it actually that because Andromeda used to be they thought it was a nebula, and then later on it got proven that Andromeda is actually outside the Milky Way, and it's actually another galaxy.
Yeah, and I think it's also partly also there's a women scientist like Henrietta Leavitt. It's about the Cepheid variables. So they use these kind of variable stars and they can calculate their luminosity period and they can determine the distance in between us and Andromeda. So after they deducing the number, it's very far away from Milky Way. So that's how they deduce, okay, it must be something outside of Milky Way. It's not something inside of Milky Way. So yeah, you're right. Calculating the distance, it's definitely something outside. So that's how like our perception of the universe changes.
So for those of you who don't know what a variable star, so yes, variable stars are used to measure or to estimate the distance from Earth. So variable stars are the stars that vary in magnitude of luminosity. Luminosity is a scientific word for brightness, and so they vary over a certain period of time. So those are called variable stars. So if I were to compare a non-variable star, is like our sun. Our sun doesn't vary in brightness over time, but there are stars out there. It's just a certain behavior of stars um, that they just vary in brightness. Sometimes they're dim. There are certain times where they're very dim, and there are certain times where they are really bright. And
Yeah.
if you were to think about it, like since I like to make jokes, I don't know if people who already like maybe bought a house or know about like mortgages. So when you go to a bank to buy a house, they ask you if you want to do what's called the variable rate or the fixed rate. So you can think about our sun as the fixed rate in terms of brightness, and those variable stars are the variable rate. So it changes, like it varies. The brightness varies.
Yeah, it's really
I don't.
interesting.
Abby's not at the age to buy a house, so she's still not doesn't know about this. But this is for you who already bought a house or maybe in the process of buying a house. I'm learning about it right now.
Yeah, I think I should like I'm at the age I should like learn about that.
You should actually. I highly recommend you. You should really learn about that and start
Yeah,
saving money. And also, uh,
I hope I'm smart enough to do that.
make sure your credit bureau is good and high. Anyhow, that's off topic.
Yeah. So maybe like now, like let's go and try to look at a different cluster. So now we're looking at a globular cluster. Let's try an open cluster.
Oh yeah, that would be great. So you'll see the between the both. So now you saw the globular cluster, which you see a lot of cluster of stars, and you're gonna notice that with the globular cluster, the stars are. You notice the color. So the color kind of reflects the age. So the globular cluster are old clusters, and they are closer to the age of the universe. But open clusters are, you're going to see most of the stars are blue, which reflects that they are young. Which open cluster are we going to be looking at?
So we're now trying at M52, so it's an open cluster around Draco, the constellation of Draco.
Draco? Are we talking about Malfoy Draco?
Oh yeah, actually, yeah, you're right. Actually, J.K. Rowling did like took some inspiration from the night sky when she was writing the book. So Draco was one of them, and another I can think of it's Bellatrix, the star Bellatrix in the constellation Orion for the winter.
Fascinating. Bloody.
There are a lot actually, quite a lot.
I'm sure there's Dumbledore somewhere, or someday there will be a Dumbledore Nebula or galaxy. I can tell you, maybe one day we'll discover a nebula that looks like Dumbledore in a way.
Oh, I really want to see that. That would be really cool. And actually, yeah, speaking of like, yeah, Harry Potter, there are just quite a lot. I remember there's also well, actually, yeah, I remember like in the first book in the Harry Potter and the Sorcerer's Stone or the Philosopher's Stone for those of you like if you're living in UK, yeah, I remember there's a scene that there's a three-headed dog. So that's actually one of the mythical story from the constellation Lyra. So J.K. Rowling did definitely take a lot of inspiration from the night sky.
Oh, I actually did not know that. That's very interesting. Oh,
Yeah.
speaking of Lyra, wasn't that one of your drinks for your space shop? If you attended
Oh,
our last
that
session,
was the last
together,
one.
if you attended our last session we did together, we kind of joked about Abby. She's gonna open her own like space shop, and we think she's gonna do it. So there's like a drink called Double Double Lyra. You should try it out once she opens her shop, her space cafe. Not even a shop, space cafe. Oh, you know what? Actually, I just thought about another drink idea. Cool names for your coffee. Oh my god, sounds so weird saying this. Blue hot star. That could be like a blueberry tea, but you'll just name it a hot blue star drink. Or you'll have, and then the other one, what was it called?
The red one. The red are the cold ones. So maybe like a cold.
Does it sound weird for you? It's like it doesn't seem right when I use that oxymoron. Cold red. That could be like an ice rose tea.
Yeah, that could be. So yeah, so we're now pointed at the M52 open clusters. So yeah, sorry, there's like a patch of light in here, like the campus light. So which you will see, like if you can see the histogram in here, there's some noise in here. But I can see like it's an open cluster in here, and unlike the globular cluster we look at, this is a rather dispersed and very loose cluster and open clusters. So yeah, so this cluster, it's quite interesting that it's brighter in itself. So you can see there are some brighter stars in here, and there are less stars in the other side. So if you're looking into a telescope, you'll be able to see like a V-shaped cluster if you have a better telescope, or if you're looking into a binoculars or a smaller telescope, it kind of shows up as a fuzzy patch. Yeah, it's really funny. Sometimes, like for me, when I first try to look at clusters with my binoculars, it takes a little bit of time to adapt and to learn how to recognize a cluster because they they are they are not really well resolved like this one because binoculars are much smaller, so they usually shows up as a fuzzy patch, and it actually takes time to learn how to recognize all of them.
I didn't know there was a way. I just thought it would just look like a fuzzy patch.
Yeah, like there are some difference. So when I looked at a globular cluster, it's actually very circular, very spherical, kind of a fuzzy globe. And for open cluster, they tend to be they're also a fuzzy patch, but They are actually a bit irregular in shape. I remember last year when I was trying to look for the wild duck cluster, it was like a harder target because it's smaller, relatively in size, and it took me 2 nights to actually hunt for it without using a go-to or a computerized telescope. And
So now you're an expert in the wild duck. You find the wild duck. No, I
yeah,
don't
it's actually a bit hard. And I remember,
why I'm Pokemon right now. When
yeah,
I said wild duck, is there a duck? A Pokemon duck? Why am I thinking about Pokemon all of a sudden? Anyhow,
yeah,
so
you like
so you
Pokemon.
so you always use your binoculars to hunt for to do stargazing. Where do you go? So I usually go to McDonald's Park in Abbotsford because it's really dark out there because you want to stay as far away from the city light or the city pollution. So the further away from the city, the darker the night sky. I know there's also Portico. Portico is also a good place for night gazing or stargazing. Where do you go, Abby? Like you always do. You seem like you always do
I
stargazing
For
or
me,
binoculars.
it's very like urban type of stargazing. I usually just like go pop out to my like balcony and then I just like take my binoculars and then just looking at the night sky, like a method called like star hopping if you're not using any tool, if you're just using a sky map and trying to find it yourself. That's called star hopping. So usually my method, I would try to look into my map, I try to find some brighter star as a reference and then just point towards slowly towards the target. So when I find a fuzzy patch, I would know, okay, yeah, that's the thing that I'm looking at and that's the cluster or the nebula or the galaxy I'm trying to look at. But yeah, like binoculars is a really good starting point to learn stargazing because it's actually easier than a telescope. And what I like about binoculars is that it has a wider field of view. You can look at like more stuff at the same time, so it's actually easier for you to recognize the night sky.
That's so cool. Do you have any recommend if somebody's trying to do this from, just to start? Just one day somebody decided to start buy binoculars and then just start stargazing. Which which do you have an object that you recommend for beginners, especially when we live in Vancouver and in the northern hemisphere?
Well, for me, like my binoculars, I didn't really buy it personally. It's actually a gift. It's a brand called Pentax, but I think a Celestron actually also works. So a 10 by 50 binoculars is a really good starting point. You'll be able to find different targets. You can see the Orion Nebula. You'll be able to look at the double star from Vega, and all the other like fun stuff in the night sky.
Yeah, if I were to recommend something, I would say the Dumbbell Nebula. Dumbbell Nebula is one of the brightest nebulas. We don't have it today because we've shown it so many times. So we want to focus on more newer ones. But yeah, no, the Dumbbell Nebula, I think it's a good one. It's one of the brightest ones in our night sky, the northern hemisphere. Another one, Andromeda. I think it's also possible to see Andromeda with the naked with actually you can see Andromeda with the naked eye, but why not use the binoculars to look at it? Andromeda is the closest galaxy to us, if you don't know what Andromeda is. And fun fact for you, if you don't know that, Andromeda will merge with us one day with the Milky Way.
Yeah, it will eventually merge with us. So some people they might kind of like freak out. Oh my goodness, is it gonna be okay, or how are people gonna survive? So actually, galaxies like you might thought of them like as a really giant structure, but they're actually really like loose gas. So it's actually more like throwing two patches of sand together, and yeah, that's how it looks like. So So now that like we're like on the star clusters, we've talked about stars. So what about moving to a nebula? What do you think about it?
Yeah, travel. Let's travel to a nebula. Woohoo!
Okay, so now let's set our
Nebulas
coordinate.
take an actual celestial object in terms of like whether we a planet, a star, or a nebula or a galaxy. I would say nebulas are my favorite thing to look at because they're so colorful and they have shapes to them. Actually, and supernovas. I would say supernovas as well. I think supernovas are also cool to look at. They're like similar to a nebula, but in a different way.
Yeah, they're
What about,
really cool.
what about
So
the people out there? If you were to pick a target or a category, what's your favorite? There's
Sorry,
planets,
which one?
stars, star clusters, galaxies, and nebulas, and supernovas.
So, yeah, let's engage and see. Hopefully this will go well.
Which nebulas are going to?
So now we're pointing at a ring nebula. The M57 nebula in the constellation Lyra. Yes, we're seeing something.
I like Ring Nebula. It's a pretty nebula.
It's very pretty.
Oh, I see something.
Yeah, I can see something too. I'm excited.
So with nebula, so when a star dies, it sheds it's all its gases. So it starts, all stars are made of hydrogen gas, and then once they run out the hydrogen gas, they go to the next element in the periodic table, if you know it. The next element will be helium, and then the third one will be lithium, and so on. So interestingly, when those elements are in a heated form and with high pressure, they actually give off a color. So actually, every element in the universe will have its own color print or its own shade of color. And for hydrogen, it's going to be in the red shade. And I think for oxygen, it's more bluish. So that's what we're going to see in the nebula. So you get to see like the different colors. And that's why I like nebulas. They're always colorful.
Yeah, they're very colorful. And yeah, I really love nebula. They're really interesting targets, and especially ring nebula. It looks like a rainbow. I really like. It's one of my favorite objects too. I know I have a lot of favorite like nebula and a lot of favorite objects.
Really, you like colorful stuff.
Yeah, I really like colorful stuff. So some people might ask, like, what's a planetary nebula? We mentioned earlier that they're not planets. They're called planetary nebula because early astronomers, like, when they're looking at the telescope, they thought, oh yeah, maybe that's a planet, but they're actually not planet. So what these are, you mentioned about white dwarf earlier. So they're the white dwarf stars are really, really old, medium-sized star, just like our sun. So as they grow older, they will accumulate a lot of pressure in the middle and they'll grow bigger to a red giant star. So what happens afterward is that they will blow their outer layer and outer layer of material into the space, so leaving a form looks like this, like what we have here on the computer screen, a planetary nebula. And white dwarf stars are actually something that's really, really dense. So they have the mass of our sun, but they have the size of the Earth. So you can imagine that compressing our sun into the size of the Earth. So that's kind of like the gist of the white dwarf star.
Or I like to call them diamond in the sky, or diamond in space, whichever way you want to call it.
Yeah, a diamond on the ring. So maybe that's a perfect gift. Like if you have someone around you really like who loves astronomy, you can show them a ring nebula, or
There you
as a
go.
gift. There's a
There you
diamond and there's a ring.
There you go. It's like, here is a white dwarf.
Yeah.
Oh, the straighteners out there. There you go. That's how you're gonna propose. You're gonna say this is a white dwarf. You're not gonna say, here, I had brought a diamond. No, I brought you a white dwarf.
Yep, that's a perfect way for nerds to maybe like talk to nerds and how they feel like you like each other.
You're still young, Abby. Is this how you want to be proposed? So we can let the people out there.
Oh yeah, that's definitely like how I wanted.
Okay,
Yeah.
you heard the women.
Yeah, so yeah, Planetary Nebula. So in this angle, like it looks like a face on a really flat nebula. But in reality, I can show you like a video in here that actually like how it looks like. So here it goes. I can show you yeah, I think the video is showing up. So you can look into this video. So it's actually a torus shape. So torus is like a math term for a donut-shaped object. So look at the red part and the yellowish gas. So it's like a ring in here, and the blue part is actually like another globe coming through in the middle of the ring. So yeah, it's like a ring nebula from a different place.
So Abby, I think they didn't see it, so the video is kind of lagging. So I don't think they saw the video. It's still like it's frozen for them. So I'm not sure if it's just on my end.
Okay. Yeah, I can see it's a little bit frozen. Sorry,
Yeah.
folks.
Yeah, they all say it's lagging, so it's just it's frozen on the Ring Nebula, the one that we are facing, which is looks great. Like you see the actual probably the white dwarf is already in the middle of the star. Sorry, the middle of the nebula.
Okay, I can see, like, I think we're back on the stream. So, yeah, they can hear it all, but it's lagging. Okay,
Let's see. Okay, so that's kind of out of our control. Video issue. I blame the heat, honestly. I think it's the heat. Because yesterday when we were testing this, my internet was so bad. I was like, why?
yeah, okay, I can see it, like, on the end now, but here it says it's lagging. Okay, yeah, I'm so sorry, everyone, and, let's see if there's anything I can resolve right now. Okay, ring.
Yeah, the video is somewhat lagging. I'm looking at the YouTube link.
Yeah, I can hear someone said it's so laggy, but I think it's been on and off now. Like, I don't see a spinning thing in here. I saw the video. Okay, someone said they saw the video, so,
Yeah, maybe I'll just put it in the
put it in the chat, and let's see if everyone hears us and see.
Yeah, maybe just put it in the chat, and then they can take a look at it, and you can still like explain the video.
Okay. So let's try it again. So can anyone hear us? Now I can see it's resuming to the stream. So just want to test the audio to see if it's working. Okay, people said they're seeing the stream now from Telescope. Yeah, so we have just turn off like the video. Heat vs Wi-Fi. Yeah. Okay, I think the stream is returned to normal. So yeah, sorry everyone for the tech issue. So we're now doing the audio testing and the stream test again. So can everyone hear us?
Yeah, I was just telling a colleague about in terms of like when it comes to astrophotography, there is winter photography versus summer photography, and it's the winter photography. The images look a lot better because the air is crisp and the light goes through much better into our atmosphere to reach the telescope or our camera. While in the summer, because of the heat, when the light goes through, like when the light goes through our atmosphere, the light gets diffracted, and so it's not as the image doesn't look as great. I don't know if people notice that, but I think people who do astrophotography for a long time, they probably notice the difference between summer photography versus winter photography.
Okay. Yeah, I'm just like trying to increase like the video bit rate, and I think it'll work better. Okay. Yeah, someone's in the chat said it's getting better, so yeah, that's good. Yeah, the audio works. Okay, thank you so much, everyone. Thank you for being so patient. So yeah, so I guess like we can go on. People, we can see it too. And yeah, so do you want to see a different target? We can look at another planetary nebula.
Let's move on to another
Yep,
destination.
let's move on. So let's set our coordinate.
What's our next destination, Abby?
So our next destination is the Blinking Nebula.
Ooh, that's interesting. Blinking Nebula.
Oh, okay. Thank you, Indira. Thank you, Jennifer. Thank you, Zach. Yeah, thank you, everyone. Yeah. Okay, the audio is working. Great. Yeah, so this is called the Blinking Nebula. It's because, yeah, there's some special way to actually see it blinking, but it doesn't really mean like it's blinking like from time to time. So when you're doing stargazing, there's a method called the averted vision. So this is also one of the things when I first started learning stargazing. So if for some fainter objects, it's actually better off if you're looking slightly off the target rather directly at the target, because if you're looking directly at the target, the bright light will overwhelm your vision, so you couldn't see the nebulosities. So if you're looking slightly off the target, you can actually see the nebulosity of the nebula or some like fainter objects. So if you're doing this back and forth, like looking directly, looking like a bit away from it, looking directly and a bit off target, you can see it's like blinking. So that's why it got its name, the Blinking Nebula. So yeah, so here's like the nebula, the Blinking Nebula we're looking at right now. So now I'm adjusting the histogram, trying to see yeah, nebula. So trying to see yeah, now I'm just adjusting the oh, okay. Sorry, it's the stream again. Yeah, I think it's a little bit lagging. It's lagging a lot. Okay. Um, Never mind.
Curious, do you actually see the Blinking Nebula? So she moved from the Ring Nebula. I'm just wondering, are the audience seeing the Blinking Nebula? It's very different.
Okay, so I think maybe now we have a bigger lagging in between, but yeah, okay. Okay, I think people are seeing, because I can see people talking about bling bling in the chat, so I think we have a bigger lagging time right now. Yeah, so Joanne also said there is a very long delay, but it's okay. I think we can just go on and talk about it. Yeah, so as we're talking about, like, this is the Blinking Nebula, we're looking at, so you can use a method called the averted vision to look at it. So, yeah, the very bright stuff in the middle is the white dwarf star, and the stuff around is, like, the material it blows up.
Yeah, we're just waiting because I'm looking at the stream with the audience, and we're just waiting for the image to show. We already have it faced towards the Blinking Nebula, and it's quite beautiful. It's a very interesting nebula, but I don't see it on the stream. I don't know if anybody is seeing it. Of Blink, that's funny. But how far is the Blinking Nebula actually? I'm curious.
So the Blinking Nebula, it's
Oh, I see something.
yeah. Oh, great. Yeah, I see something. So I think it's a very long delay. Yeah, I can already see like some people talking about it in the chat about the stuff. Yeah. So yeah, everyone says they can see it now.
That's awesome. Yeah, I think so. What people don't know is that we have a 30-second delay, or not today, obviously, but on regular better days, that we have a 30-second delay between the stream and the present time. So you're seeing it more 30 seconds later. But you see it, it's showing up.
Yeah, it's showing up. And yeah, we're seeing a fuzzy patch.
Yeah, it's so pretty. I honestly, just speaking of, like, I don't know if people can see this, but I see Saturn in it. It looks like there's a Saturn inside that bubble.
Yeah, I agree. It actually looks like there's a Saturn in the middle. And yeah, I think with that delay, we can just go on talking and keep the lagging, just like let it go natural. They will just hear all our stuff eventually. Yeah, so it actually looks like there's a Saturn in the middle. It's a really pretty nebula. I really like this nebula a lot. I've never really looked into a telescope or binoculars, but that's my next target and something I'm trying to look at for the next.
We can call it bubble. No, sorry. We can call it Saturn in a bubble. That's one of the drinks, name of the drinks.
Oh.
Saturn.
Saturn in a bubble. Yeah, it looks like Saturn. It's like very pretty.
And it's it's 2,000 light years away from Earth.
Yeah, it's really far away from Earth.
Thing. So the light it took from this nebula to reach our eyes, it lasted 2,000 years. It took 2,000 years to get to our eyes. So I'm trying to think if there would be a civilization to look at us, because we're only 2,000 we're 2,000 years apart. When do you think they'll watch the COVID hitting us?
Yeah, like, they will. They definitely will see
towards us. Huh?
They will be able to see like COVID happening to us like 2,000 years later, like if there's any civilization in there.
Very interesting. So we'll have to wait 2,000 years later for them to see us going through the pandemic.
Yeah, which hopefully it will be ending soon and we could like meet under the stars and under the dome very soon.
And actually go back to the observatory and go, look through the telescope instead of the camera.
Oh, I miss those days.
Those were the days.
Yeah, those were the really good days.
Well, we'll see. We'll hope. Things looks going well. The cases are getting less and less. Fingers crossed it keeps getting less. Maybe we'll open. I know maybe we'll get back in September. I don't know. Don't quote me on that. I don't know anything. But I really, really hope so.
Yeah, let's finger crossed as if you were approved like an in-person event in the fall. So, Yeah, so now that we have looked at two different planetary nebulas, we also have another planetary nebula prepared. So yeah, we can go and see it.
Today, I like how today is all about nebulas. Last session that we had, it was all about galaxies, and today is all about nebulas.
Oh, we have galaxy on our list, so now we are actually kind of trying to zoom like into a different perspective. So first we look at star clusters, and afterwards we look at nebula. So that's how like one single star behaves like when they get old. So later we'll see like what how this look like when there are a lot of stars, different clusters and nebula. So how does all the thing build up like and how would it look like?
Our next destination.
So our next destination is the NGC 6210, the Turtle Nebula.
Ooh, you know what? You should look up the Turtle Nebula, how it looks like after watching ours. But if you're curious, let's go to the Turtle Nebula. It's called the Turtle Nebula because it actually looks like a turtle.
So now, yeah, here we're just waiting for the dome to salute into the target.
Which is actually when, like, for a nebula, because usually you always think about the nebulas, they're more spherical shape. So for the ones we've been seeing or we've been looking at, but the Turtle Nebula it has a shape, which I've never seen. I've never seen a nebula with a shape. I think that's probably gonna be. I think let's say the Turtle Nebula is the first one I've seen with a shape. It's turtle in space.
Yeah, let me clear that again. I think we're still picking up some signals from the last one. So yeah, clearing, make sure everything is clear, that we're looking at the right object without other like frames interfering in. Yep, here we go. We're looking at the Turtle Nebula, which is this blue little blob in here. Yeah, so here we go. Here's the Turtle Nebula. It's
Well,
very beautiful.
it's still lagging. There's still a delay.
Yeah, it's okay. I think we can just let the lag like naturally, because there will be there's naturally like a minute or two delay in between, so we can just go on and talk. Yeah, we don't have to worry about that. Yeah, so now we're looking at the Turtle Nebula. So the Turtle Nebula is also another planetary nebula, but kind of like you say, it has a rather irregular shape. So the Turtle Nebula is around 6,000 light years away from Earth.
You say 6,000? 6,000?
Yeah, it's 6,000 light years away from Earth.
I'm gonna wait. I want to see how it looks like in comparison to when we saw it yesterday.
Yeah, so this is the view like from our telescope. So if you look into other Hubble's image, it might look a little bit different. So this is this is Hubble's telescope image of the Turtle Nebula. You can see like there's the head, there's the shell, and maybe there's the hands and the legs. So yeah, it looks pretty cool.
Oh my God, that's Donatello. Does anyone remember Donatello from the TV show, from the Ninja Turtles? Anybody watches the Ninja Turtles? I was actually reading the other day. There's an episode The one from the 1987. There's an episode called Beyond the Donatello Nebula. I'm wondering if that's why this nebula. I wonder if there's a connection. I don't remember the episode. I've watched them a long time ago. But I'm kind of curious if there is any connection between this nebula and the name of this episode.
Yeah, there might be. Like people like one thing I like about astronomy is that like you can take inspiration basically from anywhere, and different people they just like perceive different nebulas like in different shapes, so that actually gives you a lot of room for imagination. Like some people they think it looks like a turtle, some people they think it looks like maybe a different animal. That's something I really like about the like astronomy. You can just be very imaginative, like just imagine and visualize something that you like.
I don't think I can unsee the turtle in this. It really looked to me like once you said turtle, it looks like a turtle.
Yeah, it does. And
maybe I can just maybe change the angle. Maybe I can see something else. Oh, you know what? When I see the Hubble one, oh, I can see it on the screen now.
yeah, I think there's like around like a minute or two delay, like so it's okay. We can just go on and talk. And yeah, some people they like kind of question like why there are some differences in between the image from Hubble's telescope and from like the image we take on Earth. One of the reason it's because Hubble's telescope operate above the atmosphere, so which actually it's subjected to other rays of light, such as the X-ray or the UV light. So you're picking up a lot of different signals in a lot of different ways. But on Earth, because our atmosphere naturally diffracts away the UV light and the X-ray, it's actually kind of protecting us like from those harmful like lights. So that's why we are seeing like a rather different image, a more visible light image on Earth.
Fair enough. I like what Jennifer, she made a comment about the nebula. So they're a fancy name for blob in the sky. I like it.
Yeah, that's right.
Blob. Many blobs in the sky.
A lot of blobs in the sky. So, now that we have looked at like nebulas, so maybe let's see how does it look like when a lot of nebulas, a lot of stardust, a lot of different stars in star forming region forms. So now maybe let's look at a galaxy.
Ooh, which galaxy? Are we leaving the Milky Way?
Yep, we're leaving the Milky Way, you're right. We're exploring places where no one has gone before. We're setting coordinates and we're engaged. Yep, we're switching the telescope, so now I'm gonna clear the previous animation.
Person riding a broom? Because they're looking at the Hubble image of the Turtle Nebula. Someone says it looks like a person riding a broom.
Oh, yeah, I think it does look like someone riding on a broom. And now that like I've thought about earlier, we're talking about Harry Potter, it looks like someone playing Quidditch.
Now I think of a crab. I see like a crab, like the middle, or what's supposed to be the shell of the turtle could be like a crab, and then the leg would, well, I guess that would be its leg.
Yeah, we're pointing at the galaxy now.
Which galaxy are we visiting?
So now we're visiting M64, the Black Eye Galaxy.
Ooh, oh, the Black Eye Galaxy. That's a very, very interesting nebula.
Oh, it's actually a galaxy, not nebula.
Did I say nebula? I'm sorry. I could swear there could be a black eye nebula. Wait, there's a cat eye nebula. Sorry about that. Yeah, there's a cat eye nebula. That's why I'm
Similar names.
that's confusion.
Yeah, so
Eye, black eye, red eye. So many eyes out there in space.
okay.
Actually, if you were to even look at the 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 black eye galaxy, like you look at the Hubble telescope, it's actually a very, very interesting galaxy. Like the way it looks, because there's like the face-on galaxy, like the can't think of an example right now. The pinwheel galaxy, it's like a face-on galaxy, so you can see the center and the arms. And there's also an edge-on galaxy, which you only see. It's literally like the name suggests, it's an edge. You don't see the center, but you do see the jets that's coming out from the black hole. But with the black eye galaxy, it looks like it's a semi edge on and semi face up.
Yeah, it's kind of somewhere in between, like for me also.
Yeah.
Yeah.
And going back to that 3D versus 2D feel, if you think about it. So
Yeah, it's very interesting. Yeah, so yeah, here's the Black Eye Galaxy. Yeah, sorry here it's not stacking. So actually, like how we're doing this like virtual stereo night, we take light image, we take a lot of like short exposure, different shots, and we stack them together. So the reason is because a lot of celestial objects are really faint objects. A lot of pictures you see like on the Hubble telescope on the internet are actually a result of stacking multiple or maybe sometimes like over hundreds or thousands of frames. So that's actually how you can actually see a really faint galaxy and to see how it actually looks like. So yeah, probably here there aren't enough stars, so that's why it's not stacking. But yeah, I'm really like glad and I'm surprised. We can still see like the core in here and the black region that's like here in the galaxy.
yeah, that's a very beautiful galaxy. I highly recommend looking at the Hubble. And actually, even the Black Eye Galaxy, I think that's the one that has a very strange behavior in comparison to other galaxies. So if you don't know this, so with galaxies, you have the inner region where you have the black hole, and you have the outer region, that's where the arms. So the stars within the galaxy, they rotate, and so as the gas. They all rotate in one direction, the inner and the outer ones. But that particular galaxy, the Black Eye Galaxy, it has a very strange behavior. The gas in the outer, like in the outer region of the galaxy, it rotates in the opposite direction of everything else, of the other stars and the gas in the inner region. And I was trying to figure out a reason why this is happening, like why you have all of a sudden the gas is going in the opposite direction, because then you'll think about the gas in the ones that are rotating in the opposite direction, they will be colliding with the stars. And so the only explanation I can find on is that the theory is that could be like this galaxy could be already there's already two galaxies that already merged billions of years ago. So they believe that this black eye galaxy is merged with another galaxy, and that's the solution, the result of it. But that's just a theory. So, unless somebody else has more information on why this galaxy has that strange behavior.
Yeah, and actually like this like really like brownish region, it's actually like a dense region, like a star formation region. So yeah, that's why you can see like there's a really brown and dark lane in there. And I think that's maybe how it got its name, like Black Eye Galaxy. And in some version it's called the Evil Eyes. I'm not sure why, but yeah, there's the word eye in it.
So Jennifer's saying that they can hear, or they're losing our sound. How can you hear me now, Jennifer?
Yeah, let's see. Yeah. So okay.
Maybe show
So
a picture. You have it. Can you show an image of
yeah.
the Black Eye galaxy?
Yeah, let's go ahead and show an image of the Black Eye Galaxy. Okay, one of us, yeah, I know, like, I sound a little bit, like, robotic. I'm not sure right there may be a tiny echo, but yeah, I'm afraid it's not something I can solve right away. I'm so sorry about that, everyone.
Maybe Abby is a robot. I'm just kidding.
Oh, yes, I'm Mr. Data. I'm an android.
There you go. Hello,
Yeah.
Data. You know
So,
what? You are totally a Data. What did I think about that?
So here's an image of the Black Eye Galaxy. As you can see, like there's a really bright core in here, and there's a lot of like dark dust lane, really like blackish, brownish region in here. So yeah, here's the M64 Galaxy, and this is how it looks like.
Beautiful.
Yeah, it's really beautiful. So yeah, as summer is coming up, maybe you want to look at some like really beautiful summer targets.
Yeah.
Yeah,
What do you have on the list?
we have the really um yeah we have the so now I'm planning on looking at the Eagle Nebula.
Oh, we're back to a nebula now.
Yeah, we're back to our own galaxy. We're home.
Okay, awesome. Jennifer says she can hear us.
Yeah, she has to refresh.
The Eagle Nebula is also it's huge and very beautiful. So what you gonna see on our screen is that we can't really show the whole nebula because it's, as I mentioned, it's huge, but we'll see part of it. And what we want to show is what's called the pillars of creation. And do you want to talk about that, Abby?
Yeah, sure. So now let me try to get the nebula out.
Or maybe we can wait. Once she gets the image and she can point out to it.
Yeah, so yeah, it seems that like summer is actually great time like for stargazing. We don't have as much rainy days, but actually like, one of the challenging things for summer would be the humidity. It's quite humid here in the west coast. Hot weather is like better for stargazing, but the humidity could sometimes kind of like ruin the situation because there are a lot of moisture in the air, and the moisture are absorbing the light. So yeah, sometimes like so the best condition for stargazing would be in a desert, which is like very warm or hot, and it's very dry. So there are no moisture in the air that absorbs the light from the stars.
Because it's very cold and freezing in the desert at nighttime.
Yeah, it's actually good. Yeah, so here's like our image of the Eagle Nebula. You might see like a lot of really pinkish color around. It's because yeah, this is a really big nebula, so it won't fit into the field of view of our telescope. So you're only seeing part of the very like giant pink nebula. So here, yeah, I think we see it here. This region, the pillars of creation. Yeah, I think we can see it here. It's okay. I'm glad I can see it. glad we
So
can
the
all
reason
see.
why they're called the pillars of creation is that because, so as I mentioned before, if you remember what I said earlier, is that the element hydrogen is reflected, it has the color red, or it has the shade of red when it's in the heat form. And the pillar of creation is just the region where there's stars formation. That's how it got its name, pillar of creation.
Yeah, it is. So, yeah, if you have looked into some of the image of the Eagle Nebula, it's a really pinkish nebula with a lot of random dark black patches here and there around. So these dark patches are actually some star formation region. So they are really dense, like those region like contains a lot of like dust and gas. They're very dense. So that's why there are no background lights passing through it to kind of like shine the gas or that you can see a color in it. So that's why it's kind of like pitch dark here. But yeah, those are the star formation region. And let's see if we can enlarge this part of the pillars.
The image looks really good. It looks better. It looks way better than when we saw it last night.
Yeah, the previous night, like we have like the super moon of the year. We have a really large moon, so that's why we couldn't see it. But yeah, here you can see like here it looks like a pillar, really long. Yeah, it's really long, so that's why it's called pillars. And here there are the pink globes and stuff. Yeah, and there's a star cluster alone. So yeah, I tried looking into the Eagle Nebula with my own binoculars. It wasn't very successful. I can only see the star clusters like behind it. I couldn't see the nebulosity of the pillars and the nebula. But yeah, it's a really beautiful summer target.
It looks beautiful. Even like on your with our telescope, it looks beautiful.
Yeah. Wow. Summer. Yeah, actually, like this is like, yeah, I think it's really beautiful. There's a lot we can talk about, and I just love it. There are a lot of Hubble's image of the pillars of creation. I've seen a lot of them, and they're really amazing.
So I don't know if we mentioned earlier. So we talked about planetary nebula. So planetary nebula, the ones they're spherical or roundish, the ones that would have like they would likely have a white dwarf in the middle. Those are a star. It's a star death nebula. But the ones that we're looking at right now, those are star birth nebula. And you can guess with the difference between a star birth versus a star death. The star birth they tend to be more on the red pinkish side because you need hydrogen to create the stars. So that gives you a hint whether when you look at a nebula, that gives you the hint whether it's a star birth or a star death nebula.
Yeah.
Or a planetary nebula. Now that's the action. That's the name for it. The star death nebula.
Yeah, it is. And maybe we could go to like another target, another really like great summer target. What do you think? Yeah, we can like try M17, which is actually really close by to the Eagle Nebula.
Ooh, is it also a bird type of nebula?
Yeah, it's also it's a bird. Yes, maybe like kind of bird. This one is a bird, so yeah, it's a bird. Yes, sorry.
I guess you're right. That's amazing. All the birds locked together.
Birds are cute.
So we're gonna be going to the Swan Nebula, I'm guessing. Right?
Yeah, we're going to the Swan Nebula.
It's in Sagittarius. The constellation Sagittarius.
Oh, it's coming out. It's coming out. So yeah,
Wow,
to
look
reduce
at
the
that.
green level.
It looks good.
Yeah, beautiful. Yeah, so this nebula actually kind of like got its name because of the shape. So yeah, as you can see, yeah, it actually kind of looks like a swan. So you can assume here it's kind of like the body of the bird, and here's the head and the beak all together. So yeah, it's kind of like an upside down swan, but yeah, it's beautiful.
And you know what? I'll let you guys decide whether this is a planetary nebula or is it a Earth nebula. Put it in the chat based on what you see. If you were to guess.
Yeah. So yeah, I really like this one nebula a lot. So actually, like if you're looking into it, so this is called an H2 region, or some also call it like an emission nebula. That might be something like to so for all of us to decide. So you can see like a lot of pink gas in here. So actually, like why can you see like a really pinkish nebula? It's because there are some stars shining like beneath the nebula. So you can like it actually kind of like lights up the air, so that's why you can see like a really like gaseous object in here. But yeah, it's a really beautiful nebula in my opinion.
So far, in terms of object we've been seeing, this is the clearest one. But then again, it is much later in the night, so like that explains it too.
Yeah, it's much later in the night, and
I'm so happy. This looks way better than what we see yesterday.
yeah, so it's actually nice because the moon is so not. Yeah, the moon just rose right now, so yeah, we have a little bit of darker condition compared to last night. Last night was really bright. The previous nights was just like really bright, and the moon just kind of washed out all of the objects. So some people actually say, yeah, if you were to image, like, it's actually better to prevent like yourself to imaging on a full moon night. But you know, in Vancouver, weather is very unexpected. If you were really need to like if you were in a situation that you need to image like on a full moon night, it's actually better to go to star clusters because it's less likely to be affected by the full moon glow. So it won't be really like it won't be overwhelmed by the full moon. But for nebula, since they're fainter objects, it's very easy to be overwhelmed by the glow of the moon. So if you want to image or you want to look at some nebulas, it's better to do them on a new moon night. And for other star clusters, you can do it just like maybe like all the time, kind of like this is why we plan having some star clusters earlier in the evening rather than later in the evening. Yeah, it's coming through.
That makes sense. That makes a lot of sense.
Yeah, the pictures are stacking, like it's very beautiful. So now here, like we're looking at an image like with like 4 minutes of stacking. Yeah, beautiful.
Oh, somebody was asked. There's a question in the chat. They're asking about the stacking photons of light with telescope. Could that be used for microscopes? So there is the concept of stacking images exists with microscopes. I know because I did my master's in neurodevelopment, so we use a confocal, and it has the same concept. We use the same concept of stacking images.
Yeah, it's very beautiful.
I hope that.
So I think so. It's 11.